In our last section, we're just going to go over a couple word problems here. I'm going to do 3 of them here just so we can refresh our memory on how to do them. But the most important thing is to try to understand what's happening in the problem with no math. And what I mean by that is, can you explain the situation? Then you want to come up with things that you know about the problem. Finally, carry out a plan, and then check, does the answer make sense? So we'll look at this first one here. And these are just taken directly from your book. In fact, here I could show you where I got them from. If you go into the textbook, here is section 112. All right, and all I did was just turn the page. And I got a couple of them from here. So let's go ahead, let's go back and let's do a couple of these. So first, approximately 6.9 million wrecked cars are recycled in 2 consecutive years. There were 500,000 more recycled than the second year and than the first year. How many are recycled each year? So what are we doing? That's, like I said, that's always the first thing. What are we doing? Well, in this situation here, we're just recycling cars. That's it. All right, now, what do we know about this? Is it 1 year, 2 years, 5 years? Well, it tells us 2 consecutive years. So that's back to back. All right. Now, what they want to know, all right, is how many cars are recycled each year. So here's what I know. I have year 1 plus year 2. And the total amount of cars, when I add these 2 years together, has to equal 6,900,000. Now, they don't tell us anything about these years. All they say is, and this is the most important sentence in this entire problem, all they tell us, there were 500,000 more recycled cars the second year than the first year. So I have no idea how many cars were in the first year. But what I do know is in the second year, there were 500,000 more. So what I'm going to do is I'm going to let X equal the number of recycled cars in year 1. Because I have no idea what that is. However, year 2, I know that's going to be the number of recycled cars in year 1 plus 500,000 more. So year 2 is going to be X plus 500,000. And that has to equal 6,900,000. So from here, now the algebra part's done. I guess setting up the word problem. Now I'm just going to do some math. So we get 2x plus 500,000 equals the 6,900,000. We'll subtract 500,000 from both sides. That gives me 2x equals 6,200,000. Oh, bad math. 9 minus 5 is 4. 6,400,000. Now you know why I turn the comments off in the videos, because people will yell at me. Finally, divide both sides by 2 to give me x equals 3,200,000. Now, this number represents year 1. Okay, we still need year 2. Well, year 2 is going to be the amount of year 1 plus the 500,000. So year 2 equals 3,700,000. And here are our 2 answers right there. All right, now the next problem deals with a ski lift. So a ski lift takes a skier up the slope at 50 meters per minute. Then the skier skis down the slope at 150 meters per minute. If the round trip takes 24 minutes, how long is the slope? So once again, no math. What are we doing? Well, we have like a little mountain here. All right, so here's our mountain. We have a ski lift, so here's the top of the ski lift. Here's the bottom of the ski lift. And we have our skier going down and then riding it back up. So no math whatsoever. I understand the situation. I have two things happening here. I'm going down, then I'm coming back up. That's really important for us. So let's start labeling some things, okay? We're going to call the length that this skier slides down, we're going to call it D, all right? And we're also given that the round trip is 24 minutes, all right? Now, the one thing is definitely for sure. The trip going up is different from the trip coming down because the numbers going up the slope is 50 meters or 50 meters per minute, but coming down is 150. So we know if this total trip was 24 minutes, we spent more time going up than we did coming down. That we know that. What else do we know? Well, we're measuring a distance here, right? They want us to know how long is the slope. So what we know is this, and we are guaranteed this. The distance going up has to equal the distance going down. And distance, if you remember, equals rate multiplied by time. So hopefully things are starting to make sense now. All right, we don't know the distance, but what we do know is distance equals rate times time. So we have the rate up multiplied by the time up has to equal our rate down multiplied by the time going down. All right, yeah, it looks bad. So let's go ahead and let's start labeling some stuff. Well, we know the rate up, 50 meters per minute. So we'll just put it 50. All right. Now, we don't know how long it took us to go up. We have no idea. So we're going to let X equal the time going up. But what we do know is this. On the other side of the equation, the rate going down is 150. And the time going down, remember, the total trip was 24 minutes. Therefore, it's going to be 24 minus X. In other words, let me explain this. In other words, if it took you, let's say, 20 minutes to go up the hill, oops, wrong marker. If it took us 20 minutes to go up, well, then that only leaves us 4 minutes to go down. Right? Because the total trip was 24 minutes. If it took us 21 minutes to go up, then 3 minutes to go down, and so forth. So I know going down is 24 minus X. And from here, we have our equation. All we're going to do is distribute the right side of the equation. So 150 times 24 is going to be 3,600 minus 150x. Now I'm going to go ahead and group like terms by adding 150x to both sides. That's going to give me 200x equals 3,600. Divide both sides by 200 to give me x equals 18 minutes. Now, this just tells me how long it took us to go up. Okay? We could take this value and substitute it into either one of the equations above, whether it's the left or the right, to determine the distance of this hill. So I'm going to do the easy one. The distance of the mountain is 18. Oh, sorry. Let me put it in numerical order. 50 times 18, because we went up the mountain at 50 meters per minute. So this is going to be 900 meters. And if you were to take 18, substitute it into the right side of the equation, you would get the same exact answer. All right? So there's that one. And finally, the last problem. Deals with like a mixing type situation. So a car's radiator contains 12 liters of antifreeze at a concentration of 25%. How many liters must be drained and then replaced by pure antifreeze to bring the concentration to 50%? So let's see how we do this one. So once again, what are we doing? Well, we got some antifreeze, and it's inside a car's radiator. All right. We know that there are 12 liters of 25% concentration. All right, we know that. We also know that we're going to be draining some of this. All right, we're going to be draining, and we're going to replace pure antifreeze to bring the concentration up to 50%. All right, so let's think about this here. We have the amount of antifreeze already in the radiator. All right. We know we're going to add some antifreeze. And in order for us to add it, and this is why I wrote it a specific way, because we're going to have to drain some out. And if you think about draining some out, we're going to subtract. All right. Now, this has to equal 12 liters of 50%, because that's what's considered safe. So if you think about this, all right, if you think about this, we do have an unknown variable. And the unknown variable is, can you guess? How much do we drain? All right. So this problem is basically the same exact one as what we did previously. It's just, it looks different. So here we go. The amount already in the radiator minus the amount drained. We have no idea how much we're draining, but what we do know is this. The concentration in the radiator is 0.25. The amount that we're draining is going to be 12 minus X, because you have 12 liters already in there, but you got to take some out. We're going to add pure antifreeze. So the amount drained, 12 minus X plus X. This will be the amount of antifreeze that we put in. And this has to equal 0.5 times 12. So from here, we can go ahead and just solve this. Sorry, I got to get out my calculator. All right, there we go. So 0.25 times 12 is 3 minus 0.25x plus x equals half of 12 is 6. So now I'm going to go ahead and group like terms. So I get 1 minus 0.25 is 0.75. So 3 plus 0.75x equals 6. Subtract 3 from both sides. And then finally, we're going to divide both sides by 0.75. So x is going to equal 3 divided by 0.75, or 4 liters. So the amount I'm draining is equal to the amount of pure I'm putting in. So we drain 4 liters of 25% antifreeze. And we add 4 liters of pure antifreeze. All right. And that's going to be it for this video.